Salinity is defined as a ratio between the weight of two dissolved materials on the weight of the samples in the seawater. Generally, salinity is defined as the total amount of solid material in grams contained in 1 kg of seawater and is expressed as part per thousand. The oceanic salinity goes to the fracture the marine organisms and plant communities, but it also affects the physical properties of the oceans such as temperature, density, pressure, waves, currents, etc. The freezing point of the ocean water also depends on the salinity. For example, more saline water freezes slowly in comparison to the less saline water. The boiling point of the saline water is higher than the fresh water. Evaporation is also controlled by salinity, and it is lower over the saline water than over less saline water. It also increases the density of seawater. This is why man seldom is drowned in the seawater with very high salinity. Variation in the salinity causes the ocean currents. After the lesson, you will be able to understand the layers of distribution of salinity, that is the horizontal and vertical. Seawater contains a complex solution of several mineral substances in dilute form because it is active solvent. The total amount of salt in the seawater is active solvent. The total amount of salt in the seawater is gradually increasing because it is brought from the land every year. Several efforts have been made to estimate the total amount of salt in the oceans in the series. The estimates of Jolly, Murray and Clark put the total salt in the oceans and seas at 50 billion tons and 5 billion tons and 7 billion tons respectively. According to Jolly, if all the salts of all the oceans and seas are dried up and are spread over the globe, these will form a 45.72 meter thick layer. And if these salts are spread only over the land, these will form 152.4 meter thick layer. If all the salts are removed from the oceans and the seas, they will fall in the sea level by 30.48 meters. Dittmar, during the Challenger expedition in 1884, reported the existence of 47 types of soils in the seawater, out of which 7 are most important. Sodium chloride, or common salt, is by far the most important constituent of the sea salt. Besides salts, silver, gold and radium also occur in minute proportion in the seawater. These elements are 0.3, 0.006 and 0.002 mg per metric ton or parts per thousand million. The average salinity varies from 33 parts per thousand to 37 parts per thousand in different oceans and seas. There are numerous nutrients in the seawater which are used by living marine organisms. Basically, the source of oceanic salinity is land. Rivers bring salts in solution form from the continental areas. Surprisingly, there is a lot of variation in the composition of the sea salt and riverine salt, as calcium sulfate constitutes 60% of the river salinity while sodium chloride dominates and the salinity of the oceans. River water contains only 2% of the sodium chloride. That is why some scientists do not accept the rivers as a major source of salinity of the oceans and seas, but it may be pointed out that major portion of calcium brought by the rivers into the oceans is consumed by marine organisms. Secondly, the salt brought by the rivers is bit modified in the oceans. Volcanic ashes also provide some salt to the oceans. There is a wide range of variation in the spatial distribution of salinity within the oceans and seas. The factors affecting the amount of salt in the different oceans and seas are called controlling factors of oceanic salinity. Evaporation, precipitation, influx of river water, prevailing winds, ocean currents and sea waves are significant controlling factors. Evaporation. There is a direct positive relationship between the rate of evaporation and salinity. For example, greater the evaporation, higher the salinity and vice versa. In fact, salt concentration increases with rapid rate of evaporation. Evaporation due to high temperature with low humidity or dry conditions causes more concentration of salt and overall salinity becomes higher. For example, salinity is higher near the tropics than at the equator because both the areas record high rate of evaporation. But with dry air over the tropics of Cancer and Capricorn, according to WUST 1935, average annual rate of evaporation in the Atlantic Ocean is 94 centimeters to the north of 40 degrees north, 149 centimeter and 20 degree north, and 105 centimeters near the equator. Salinity is 34.685 per thousand at 5 degree north and more than 37 parts per thousand at 20 degree north. Evaporation in the southern Atlantic Ocean is 143 centimeters per year at 10 degrees south and only 43 centimeters at 5 degrees south. In general, subtropical high pressure belt, and today it is going there, is recording rapid rate of evaporation which increases salinity, but cloudy sky with high humidity lowers down salinity in the equatorial belt. It may be pointed out that salinity also controls evaporation. Precipitation. It is inversely related to salinity. For example, higher the precipitation, lower the salinity, and vice versa. This is why the region of high rainfall records comparatively lower salinity than the regions of low rainfall. The extra water in the temperate regions supplied by melt water of ice coming from the polar areas increases the volume of water and therefore reduces salinity. It may be simply stated that the volume of water in the oceans is increased due to heavy rainfall, and thus the ratio of salt to the total volume of water is reduced. Influx of the river water. Though the rivers bring salt from the land to the ocean, but big and voluminous rivers pour down immense volume of water into the oceans, and the salinity is reduced at the mouth. For example, comparatively low salinity is found near the mouth of Ganga, the Congo, the Niger, Amazon, the St. Lawrence, etc. The effective influx of river water is more pronounced in the enclosed seas. For example, Danube, Dniester, Dnieper, etc. Reduces the salinity in the Black Sea to 18 parts per thousand. Salinity is reduced to 5 parts per thousand in the Gulf of Bothnia due to influx of immense volume of water brought by the rivers. On the other hand, where evaporation exceeds the influx of fresh river waters, there is increase in the salinity in the Mediterranean Sea, and it records 40 parts per thousand. Atmospheric pressure and the wind direction. Anticyclonic conditions with stable air and high temperature increase salinity of the surface water of the oceans. Subtropical high pressure belts represent such conditions to cause high salinity. Winds also help in the redistribution of salt in the ocean and seas, as winds drive away saline water to less saline areas, thus resulting into decrease of the salinity in the former and increase in the latter. In other words, in the areas of appellant of the water, less saline water moves up from below and hence low salinity, whereas the areas where water is piled up, salinity is increased. For example, trade winds drive away saline waters from the west coast of the continents or eastern margins of the oceans and pile them up near the eastern coast of the western margins of the oceans, causing low salinity in the former areas and high salinity in the latter. This is why the Gulf of Mexico records 36 parts per thousand to 37 parts per thousand salinity, whereas it is only 34 parts per thousand in the Gulf of California. Westerlies increase the salinity along the western coast of the continents, whereas the lower salinity along the eastern coast. Sometimes winds minimize the spatial variation in salinity. Circulation of the oceanic water. Ocean currents affect the spatial distribution of salinity by mixing seawater. Equatorial warm currents drive away salts from the western coastal areas of continents and accumulate them along the eastern coastal areas. The high salinity of the Mexican Gulf is partly due to this factor. The North Atlantic Drift, the extension of Gulf Stream, increases salinity along the northwestern coast of Europe. Similarly, salinity is reduced along the northeastern coast of North America due to cool Labrador current. Ocean currents are the least influence on the salinity in the enclosed seas, but those marginal seas which have communication with open seas through wide openings are certainly affected by the currents in terms of salinity. For example, North Atlantic drift rises the salinity of the Norwegian and northern seas. According to the vast oceanic salinity is affected mainly by three factors, where the first one is salinity is reduced by precipitation, and salinity increases due to evaporation, and salinity varies due to mixing of water of different characters. There is also temporal variation in the oceanic salinity. The oceans in the northern hemisphere recorded maximum and minimum salinity during June and December months respectively. The average salinity in the oceans and seas is 35 parts per thousand, but it spatial and temporally varies in different oceans, seas and lakes. The variation in the salinity is both horizontal and vertical with depth. Salinity also varies from enclosed seas through partially closed seas to open seas. Thus, the spatial distribution of salinity is studied in two ways: horizontal distribution and vertical distribution. Horizontal distribution of the oceanic salinity is studied in relation to the latitudes, but regional distribution is also considered, wherein each ocean is described. Similarly, the pattern of the spatial distribution of salinity in the enclosed seas, partially enclosed seas and open seas is also considered. Latitudinal distribution. On an average, salinity decreases from the equator towards the poles. It may be mentioned that the highest salinity is seldom recorded near the equator, though this zone records high temperature and evaporation, but high rainfall reduces the relative proportion of the salt. Thus, the equator accounts for only 35 parts per thousand salinity. It is observed between 20 degree to 40 degree north because this zone is characterized by high temperature, high evaporation, but significantly low rainfall. The average salinity of 35 parts per thousand is recorded between 10 to 30 degree latitude in the southern hemisphere. The zone between 40 degree to 60 degree latitude in both the hemispheres records low salinity, where it is 31 parts per thousand and 33 parts per thousand in the northern and the southern hemisphere respectively. Salinity further decreases in the polar zones because of the influx of meltwater. On an average, the northern and southern hemispheres record average salinity of 34 parts per thousand and 35 parts per thousand respectively. On the basis of the latitudinal distribution of salinity, 4 zones of oceanic salinity may be identified. For example, equatorial zones of relatively low salinity, tropical zone of maximum salinity due to low rainfall and high evaporation, temperate zone of low salinity, and subpolar and polar zone of minimum salinity. It may be pointed out that the marginal areas of the oceans bordering the continents have lower salinity than the central part because fresh water is added to the marginal areas through the rivers. Salinity varies in open seas according to the latitudes though it depends on the ocean currents further, and it has no control of the latitudes on the distribution of salinity in the inland seas. Salinity of partially enclosed seas in the higher latitudes is seldom controlled by the latitude, rather it depends on the influx of meltwater. This is why the Baltic Sea records comparatively lower salinity than the North Sea, though the latitudinal extent of both the seas is the same. Regional distribution. Regional distribution of the surface salinity of the oceans and seas is described in two ways: distribution of salinity in the individual oceans and salinity zones of all the oceans together. Jenkins has divided the oceans on the basis of variations into 3 categories: seas having salinity above normal, Red Sea with 34 to 41 parts per thousand, Persian Gulf 37 to 38 parts per thousand, Mediterranean Sea 37 to 39 parts per thousand. Seas having normal salinity: Caribbean Sea and Gulf of Mexico 35 to 36 parts per thousand, Bass Strait 35 parts per thousand, and Gulf of California 25 to 35.5 parts per thousand. Seas having salinity below normal: slightly less, Arctic Ocean 20 to 35 parts per thousand, North Australian Sea 33 to 34 parts per thousand, Bering Sea 28 to 33 parts per thousand, Okhotsk Sea 30 to 32 parts per thousand, Japan Sea 30 to 34 parts per thousand, China Sea 25 to 35 parts per thousand, Andaman Sea 30 to 32 parts per thousand, North Sea 31 to 35 parts per thousand, English Channel 32 to 35 parts per thousand, and Gulf of St. Lawrence with 32 parts per thousand. Much below, Baltic Sea 3 to 15 parts per thousand, Hudson Bay 3 to 15 parts per thousand. Pacific Ocean. There is a wide range of salinity difference in the Pacific Ocean because of its shape and larger areal extent. 34.85 parts per thousand near equator. It increases to 35 parts per thousand between 15 degree to 20 degree latitudes in the northern hemisphere, but it becomes 36 parts per thousand in the southern Pacific Ocean between the same latitudes. Atlantic Ocean. The average salinity of the Atlantic Ocean is 35.67 parts per thousand. It is not observed near the equator, rather it is recorded between 15 degree to 20 degree latitudes. Record salinity at 5 degree north, 15 degree north and 15 degree south as 34.98 parts per thousand and 36 parts per thousand and 37.77 parts per thousand respectively, indicates increasing trend of salinity from the equator towards the tropics of Cancer and Capricorn. The central zone of the North Atlantic Ocean, located between 20 degree north and 30 degree north and 20 degree west to 60 degree west, records maximum salinity, that is 37 parts per thousand, and it gradually decreases further northward but with varying trends. Eastern marginal areas of North Atlantic beyond 40 degree latitude record comparatively higher salinity than the western margin, because of Gulf Stream carries saline water from the American coast to the northwestern European coast. Maximum salinity of 37 parts per thousand in southern Atlantic is found in a region demarcated by 12 degrees south and 20 degrees south latitudes and 40 degree west to 15 degree west longitudes. Indian Ocean. The spatial distribution of salinity in the Indian Ocean is more variable and complex than the Pacific and Atlantic Oceans. An average salinity of 35 parts per thousand between 0 degree to 10 degree north, but it gradually decreases northward in the Bay of Bengal to 33.5 parts per thousand at 10 degree north latitude to 30 parts per thousand at mouth of Ganga, because of the influx of immense volume of fresh water brought by the Ganga river. On the other hand, the Arabian Sea records higher salinity, that is 36 parts per thousand, and Bay of Bengal, because there is higher rate of evaporation due to relatively less humid conditions and low influx of the fresh water as compared to the Bay of Bengal. The western coast of the Australia records higher salinity due to dry weather. The partially enclosed seas have higher salinity. For example, it is 37 parts per thousand at the head and 40 parts per thousand and at the interior of the Persian Gulf. The Red Sea records the highest salinity, bearing between 36 parts per thousand and 41 parts per thousand in different parts because of the low precipitation and very high evaporation. It may be mentioned that spatial distribution of the surface salinity of the oceans in the seas is represented by isohalines, which are the lines that join the places of equal salinity at the sea surface on the map. Inland seas and lakes. The amount of salt in the inland seas and lakes is controlled by the rate of evaporation, temperature, influx of river water in the presence or absence of the outlets. Whenever a river comes out of the lake or inland sea, salinity is taken out of the water bodies by the river. The influx of the fresh water brought by the river into the lakes and inland seas also lowers down the salinity. For example, lower salinity of the northern part of the Caspian Sea, which is 14 parts per thousand, is because of the addition of enormous volume of water brought by the rivers like Volga, Ural, etc., but it becomes as high as 170 parts per thousand in the southern part of the Gulf of Karabugas. Very high salinity is found in the Great Salt Lake of 225 parts per thousand in Utah of United States of America, Red Sea has 240 parts per thousand. Lake Van records 330 parts per thousand in Turkey. Dead Sea records 238 parts per thousand, etc. No definite trend of distribution of the salinity that can be spelled out, because both the trends of increase and decrease in salinity with increasing depths have been observed. Following characteristics of the vertical distribution may be stated. Salinity decreases with increase in depth and high latitude, that is, there is a positive relationship between the amount of salinity and depth because of denser water below. The trend of increase of salinity with increasing depths is confined to 200 fathoms from the surface in the middle latitudes, beyond which it decreases with increasing depths. Salinity is lower at the surface of the equator due to high rainfall and transfer of water through equatorial currents, but higher salinity is noted below the water surface. It again becomes low at the bottom. More studies and the data of salinity distribution at regular depths in different oceans and seas are required so that definite characteristic features of the vertical distribution of salinity may be determined. It may be mentioned that the depth zone of the oceans between 300 meters and 1000 meters is characterized by varying trends of vertical distribution of temperature, density of sea water, and salinity of the ocean water. This zone is characterized by rapid change of sea water density, increase in the density with increasing depth in the low latitudes, but constant high density in the high latitude, and it is known as the Pycno line, while this zone represents rapid decrease of temperature with increasing depth of 1000 meters in the low latitudes and is called as the thermocline. This lesson makes us understand the salinity variations in different oceans, factors affecting it, and its distribution.